Right, here's an example on acceleration. So we'll take a little guy here, he's going to have a race. Start line and finish line. Now at the start line he's going to be stationary, so his speed will be 0. He's going to travel to the finish line and his speed's going to increase to 6 meters per second at the finish line. So in this case, if his speed's increasing, we would usually say that he's accelerating. Now as he accelerates, time is going to pass by. Let's say that's 3 seconds. But how are we actually going to figure out what the acceleration of this wee guy across his race actually is? Well, when you consider acceleration, you would either consider it being an object speeding up, or an object might even slow down. Now if you're talking about objects slowing down, you might consider it as being a deceleration instead of calling it an acceleration. But the common theme between these two factors is that you need to have a change in speed. So whether you're speeding up or slowing down, to have an acceleration or deceleration, you need a change in speed. And in physics we call that delta V. That's what that triangle is. It's called delta. And it just means change in, and we know that V stands for speed. So back to the little example. Now we know this little guy, across his race from start to finish, he's going to change his speed. But what else is passing by as his speed changes? Well, we know it's time. So the two factors that are going to affect acceleration are the change in speed during that race and the time it takes for that speed to change. Or in other words, acceleration is the change in speed every second. So that's your definition. We can rewrite that. Acceleration we can have as the symbol A, the change in speed is delta V, and the time is t. So there's a little relationship in terms of symbols for acceleration, and we include the change in speed and time in that relationship. Let's look at the change in speed in a bit more detail. So how do we get the change in speed? Well, we need the speed at the start of this race, and we need the speed at the finish of this race to see what the difference is between the two. That will give us the change in speed. Now what we're going to do is we're going to use some more technical terms here. We're going to use initial instead of start, and final instead of finish. So if we do that, delta V, the change in speed, we get that by taking the final speed, take away the initial speed. Now, this relationship always stands. You must always take the final and the initial in terms of taking them away. So the initial speed is always taken away from the final speed, not the other way around. So let's look at the relationship as a whole. Now the initial speed, what we're going to do is change that to, instead of having to write these letters and words again, we can just use these symbols. So the initial speed we're going to change from V initial to U, and the final speed we're going to change to just V. So if we rewrite a relationship again, delta V equals V minus U, and if we take it as a whole, A is delta V over T, and if we substitute in our V minus U, we get A is equal to V minus U over T. And that is the final relationship for acceleration. Now let's see if we can put that into practice. So we'll finally go back to our wee guy, and he'll be able to finally do his race. Start line, finish line. Now U is the initial speed, remember, so that's 0 this time. And V is our final speed, and we said that was 6 meters per second. And we said that the time taken to do this is 3 seconds. What's the acceleration? Well, let's use our relationship from the last slide. V minus U all over T. Do the bit in brackets first. So we're going to substitute our numbers in. 6 minus 0 all over 3. So that's just going to be 6 over 3. And the acceleration is 2 meters per second squared. Now, where does that squared term come from? Well, let's talk about that in a bit more detail now. So, where is this squared term actually coming from? Well, let's take an equation that we are already familiar with, and we can look at how we get the units for speed in this case, looking at distance and time. So, the units for distance is metres, and the units for time is seconds. Now notice that metres is all over the seconds there, right? Metres per second is a unit for speed. Now let's take acceleration. V minus u over t, so the top there, right, are both speeds, so that means they're both measured in metres per second. And time, again, is measured in seconds. So it's metres per second. Now this here is just like being in the bottom, because it's got under a slash. So we need to put that in the bottom. So if we do that, we've got metres per second, second. Now, you multiply those two together, what do you get? Well, if you multiply 2 times 2, you get 4. If you do 2 squared, you also get 4. So multiplying those two things together, you're going to get a squared term. So, in that case, that relationship there can be changed to metres per second squared. And that's how we get the units for acceleration.